My name is Abdikarim Abdullahi Arab. I am Group 4. Tonight I want to record a video for the project of Calculus for Engineering. Firstly, I would like to introduce the names of my crewmate. Firstly, Situ Nur Frina Bintu Sheikh, Nur Atiqa, Situ Nur Hajar, Abdikarim Abdullahi Arab, Sahira Bintu On. Now I am going to record a video for the introduction. So the question need to answer is, what's hollow shaft? So I am going to explain for this question. Shafts are among the most critical components in any mechanical engineering project. The material from which it is made, it is first and foremost selected to suit the intended application and the demands that it has to fulfill in use. Basic requirements such as material strength, handleability, and ductility are satisfied by various kinds of structural steel. Solid shaft. The fact that it's hollow gives it a number of positive attributes that make this type of shaft a popular and widespread element of many types of machine. The main advantage of hollow shaft is it is weight saving and saves space. The process of producing a hollow shaft is far more complex than that of a conventional solid shaft. Wall thickness and diameter are not mutually configured in a relation that complies with physical laws. The resulting construction may be unstable. Lastly, the hollow shaft constitutes an essential component of the hollow shaft motor, which is used in electrically powered vehicles such as trains and also suitable for the construction of jigs and fixtures as well as automatic machines. So that's the end of my topic.
Hi, I'm Siti Nur Afrina. We will move to the next part, which is calculation. And first, I will explain about part 1. In part 1, we have to calculate the maximum value to produce a hollow shaft. In order to calculate the maximum value that has surface area of 10 pi cm cube, we need to find the radius r of the shaft first by assuming the value of h, which is 5 cm, and substituting the values to this formula. We use surface area formula of hollow shaft, and the formula is 2 pi in bracket r1 square minus r2 square close bracket plus 2 pi h open bracket r1 plus r2 close bracket. After obtaining the value of radius r, maximum value Vmax can be calculated using this formula. The formula for volume maximum is pi r squared h. So we got 0.676 pi cm cube.
In task 2, we use triple integrals in cylindrical coordinate to find the moment of inertia at z-axis, which give us equation of triple integral r squared density dz dr d theta. We substitute density with m over v, and then we perform the calculation as usual. We will get the answer in terms of m, and then we use the same formula, density is equal to m over v. We will get the value of m, and then we substitute the value of m back into the equation we have. We calculate it, and we will get the value of moment of inertia in z-axis.
Hi, my name is Siti Nur Hajar binti Bahtia. My matrix number is AD200133. So today I will present to you part 3 calculation. So for this question, we need to propose suitable dimension of the flank, then determine its center of mass. So firstly, we assume the length of a triangle, which is this is the prototype. So from y-axis is 10 centimeter and length from at x-axis is 10 centimeter. Then we find the mass by using mass for a lamina formula. So as you can see from sketch xy plane, we use a vertical strip method to determine the x and y integrals. So for y integral, we start from the bottom to top, which the lower integral is 0 and upper integral is negative x plus 10. For x, we look from left to right, where the left integral is 0 and right integral is 10. Then we got the mass is equal to 50. After that, we have to determine the moment of mass about y and x axis. So the integrals are the same with previous calculation. So after the calculation that have been made, the moment of mass at both axes are the same, which is equal to 500 over 3. And then finally, we can determine the center of mass by using center of mass formula, which is moment of mass over mass. And then the center of mass value we'll obtain is xy equal to 3.33, 3.33.
The reflection that we got from this project is we learned that integration can be used to uniting different things in an attempt to determine its exact value. So in our daily life, there's a lot of situations that can be related to the knowledge on integration. First example is speedometer. Speedometer is used to measure instantaneous velocity in vehicle. So we can control the speed of vehicle when we driving it. The second example is playing computer games. This knowledge help integrate acceleration to find velocity, then integrate velocity to find the position of the target so we can aim the target perfectly. For example, the entire gameplay of Angry Bird use this concept in order to win the game. The third example is filling water in an unknown size of container. We use the knowledge of integration to determine the shape of container so we can find the volume of the water needed to fill the container perfectly without spilling it out. And the last example is balancing watermelon on small table. Balancing semicircular object on flat surface is not easy, so we need to find the center of the mass by using integration concept so we can balance the watermelon and avoid it from falling down from the table. So this is all the discussion of this group assignment that we got. Thank you.